like it should say recording now, but let's see, it has pause, so it has to be recording. Last time it didn't record, so anyway, yeah, so she's like big up, so maybe this is inside, like if you go into the automotive files, I just parked that there, like in the bottom of automotive. That's what I'm going to cover today, but anyway, maybe you guys could figure out, like, it would be good to ask her about a bunch of things. So I don't know what she's going to talk about. She didn't give me her slides or anything. So I made a homework. So you definitely have to ask her these things because it's on the homework, right? So I said, oh, that's homework 7. There's homework 8. Did I not put up the new thing? Let me put it up. Just take a second. Oops. That thing, put this. There, homework 8. Oh, this homework 8 goes on. All right. So I said, so I don't know what she's going to talk about, but I looked. So one thing that they do is like mass balance accounting. And if you go to that, so here, mass balance, see NIST workshop. So this is what I've heard that NIST does is mass balance accounting. So it's basically, it's like when you buy hamburger and it says 70% fat and they didn't find a cow that was 70% fat. They took like all the cows, chopped them up into pieces. Then they mix in the fat, separate the fat part from the meat part, and they mix in 70%, and then you get it at Kroger. So it's like 30 different million cows went into that one hamburger thing, right? So this is the same thing, but with plastics. It's got your recycle stream. You buy polyethylene that's 80% recycled. They've kind of gotten it from all these sources and mixed it and sold it that way. And so mass balance accounting has like, it's a flim flam operation where you can easily, it's like the carbon. Have you guys ever heard of the carbon credits and carbon offset? When you go on an air flight, we can buy a tree in the Amazon or something. So basically it's a flim flam operation. It's like a Ponzi scheme, something where, right, it's not true. Like you are not buying a tree in the Amazon and it isn't going to help anything, right? So this mass balance accounting is kind of the same thing. I mean, it's the same flim flam. It could be that there's no other way to do it. There's definitely a way to do it for the carbon cycle, but there may not be a way to do it for the plastic cycle. But nonetheless, since the other, so like ProPublica is kind of like a liberal, whatever, and they're saying like this mass balance accounting is like a ripoff. And it gives a couple of things, but you can Google your own. You'll find like people are riding on it. Everyone's riding on it. They're like, this is just a lie. It's like the pyrolysis process. Like well, there might be no other way to solve the auto plastic problem because it's mixed plastics with toxic materials in it. So pyrolysis might be the only way to do it. But on the other hand, it is a flim flam. Like you're probably burning more CO2 to recycle the plastic than it would have taken to make new plastic, right? So, and you've sequestered it when it's plastics, when I just bury it, So anyway, this thing asks you to address that, but if she comes in and just starts to talk about chemistry, making bottle brush polymers, then you're going to have to stop her and say, oh, by the way, do you know anything about mass balance accounting? Is that really true or not? Or are you lying to us? Something like that, And then she should come back and say, this is the greatest thing since white bread, everybody should be eating it. It's so good for you. It's white, it's good. Something like that, right? So, I mean, or she could say like, agree with you, so basically, you're gonna have, if she doesn't talk about that, you have to ask her to talk about it. Because I don't know what she's gonna talk about, so I want to have some questions. And then she should, I'd imagine she's gonna come in, if she's like an administrator, she's gonna have a list of what everyone's doing in her place. I know there's a lot of stuff going on, so she should have at least 5 activities at NIST and plastics recycling. And then I think what I want you to do is say, couldn't that be done better at a company say the sorting operation? So developing new technology for sorting. All right, there's a million companies making sorting equipment. And then there's the like the Rumpke setup. And then there's all the plastics producers. So does NIST really need to jump into that? And there's all the universities, right? So all those people are doing the same thing. Like, why do they need to have a separate operation going on at NIST with that? I mean, it might be that you think that they're great. The advantage they have is they have a lot more money. They have, all right, so the money tree goes NIH has the most money, like they can just burn money. Then DOE has a huge amount of money. DOD has like unlimited money too. So those 3 like take up probably like 95% of the federal budget for science. And then you have NSF, which funds all the universities, which gets like 2%. So, but like I worked at Sandia, which is DOE, we had 2 levels of administration. So the overhead cut was like 200% of the amount. So the amount that, what was spent on research was unlimited. It's basically just like a huge money flush machine, right? But some research gets done. I mean, they attract good people because they pay better. They pay really high. So NIST pays lower, so they're not as high up on that tree, right? They're not the big money, but compared to a university, they're like the rich guy on the block, So kind of like they have nuclear reactors and things that they can do stuff with. So basically, it's hard to tell, Anyway, they are a player in it, and they're seen as kind of the smart people on the block. Like DOE, like Department of Defense is dumb, right? Like DARPA, I worked on a DARPA project that funded watches that you could put on soldiers. And when the guy got exposed to germ warfare, it would light up and they could make a map of all the soldiers and figure out where everyone was dying and maybe tell the other guys to run away or run towards it or whatever, So basically, that's what DARPA funds. And they funded that to like $30 million. It was a pretty big budget. It was totally stupid, right? And then, I mean, Department of Defense, that's like the smart part of Department of Defense. The rest of it is kind of like clean up a hazardous waste thing at some military base. So then DOE's nuclear bombs, and they have unlimited money, but they also do kind of stupid stuff too. I don't know. A lot of it's secret at DOE because of the nuclear weapons part. And then Commerce, though, in the government labs, they're the brainiacs. Like they're all this guys that know what they're doing, and they do it with like a little bit, like maybe 1/10 of the money, which is still a ton of money. But they're actually seen as very efficient and like very smart. So it attracts all the smart people. The DOE attracts the money people, and the military kind of attracts, I don't know, people that are desperate, more or less. Because, if you can't get a job anywhere, you can get a job in the military because it's, if you're a US citizen, right? So that's basically the same in science. So, I mean, there's some smart people, there's like some brilliant people in them, like at Wright-Patterson. But basically, in general, I think that's true. Anyway, NIST is the brainiac part, but they're lower budget, but they still have tons more than us. And then NIH is just flush with money, like unbelievable amounts. So, anyway, so you always want to question, like, is it like if you could do it for 1/10 of the money at a university, why wouldn't you do it there? Of course, university is almost like slave labor, given that like the stipends you give grad students. So there's no benefits or anything. So it's a little bit of a toss up, like what's the best place to do the work. But companies would definitely be an option, and like Rumpke would be an option. So like I want you to balance it out and say, like, does that make sense? Anyway, and then hopefully she can talk about what she did with the UN, because that's like exactly, we were going through stuff about regulations, different countries, and then the UN stuff is the international part, which basically like nothing was achieved at the UN, right? I mean, in other words, there has been no global ruling on plastics waste at all, right? If anything, it's just spinning wheels. So it would be good to hear what she has to say about it, and then maybe you could kind of critique on it. The rest of this is the stuff I'm going to do today, the automotive stuff. But anyway, so what I wanted to say was like, if she doesn't address those three things, make sure you got to ask about them. I'll try to ask, but basically she needs to address those three things. And she'll probably talk about all this stuff too. You can probably get most of this online by Googling somewhat. Like the 5 things, if you go back to her, the NIST, whatever thing that she founded, oh, this is mass balance. If you go back here, like there's at least 5 things here, like food waste, data homogenization, blah, blah, blah. So she's got, I think there's 5 here. And if you can't find 5, maybe just put in, there's some other things here. So I think there's 5 things. If you just do like circular economy NIST, you can get to that. So hopefully you can put that together. If not, just tell me like there aren't 5, there's only 1, whatever. So just do that one. But all right, so that's that. Any stuff with that, or hopefully she can hear. There's a mic here. I'd like you guys to ask questions. I think she'll be able to hear, hopefully. If not, I can translate or something, I guess. But there's a mic up here. Oh, what I can do is get the there's a handheld mic down there, so I can take that out and we can pass it around, I guess, if she can't hear. But it'd be good to kind of badger her, like not just let her get by with like giving a promo show about NIST that says like how great we are and this is the place and stuff, that would be terrible if that happens. Not terrible, but not optimal. Anyway, so is this guy still recording? That's the question. It says pause, so it has to be recording, right? Because last time it didn't record. So if I get rid of that, does it still record? It still says pause. All right. It's pretty strange because only this class do I have that problem. The other class, it's like no problem with the, let's see, didn't I already open PowerPoint here? Maybe not. Just open that again. Automotive. So I want to go through, so again, like I'm trying to go through topical things, and it turns out like automotive and electronics are coupled because they both end up with a really terrible recycle stream. It's like 20% of car end EOL, end of life cars, ELV, they call it end of life vehicle. 20% of it is plastic, so, and then same with electronics, and both of them, and same probably with airplanes, but basically both of them have bromine chemicals in them to prevent fires. Like fire retardants are brominated, and it turns out like bromine, when it combines with when it's burned, particularly makes something like dioxin, brominated dioxin, which is like the most deadly thing on earth, something like that. So basically, you can't exactly burn either electronics waste or automotive waste. So it leads to kind of a problem with the whole recycle stream. So it's a complicated recycle stream, but it's one of the first ones. It's one of the first ones that drove this whole business of plastics recycling, because the EU in 2000 said you had to recycle cars, like all the cars in the EU by 2025, I think is what they said originally. These things always get pushed back. Basically, when they said that, everybody, all right, so what should I do with this thing? I think this is where I kill my whole operation. I go like that and kill it. Because it's already recording, right? It says pause, it's recording. So if I kill that, and it still says pause, it's still recording. We'll see if it records. Anyway, so there's a few things. The Eastman Chemicals, which is in Tennessee near Knoxville, that's the place that does all the PET recycling, and they're big in this automotive. So basically, ideally you take the car, take out the catalytic converter, get rid of the seats, which are polyurethane foam and have the brominated stuff in it. Take out the dashboard, which is polyurethane foam and has the brominated stuff in it. Take out all the guts from in here, all the rubber seals, get rid of the tires and the rims, drain all the fluids. Then you have kind of a hulk of a car if you do all the things you need to do. Right. And then that thing still has plastic in it because it's got relays in it and things. And it's got little gears and all kinds of little parts in there that haven't been ripped out. 20% of it is plastic at that point. Right. So, or 20% total is plastic. But even at that point, there's a substantial amount that's plastic. Then this whole car is going to be probably compressed into a bale. Right. And then that bale is going to be fed into a shredder. And the shredder is going to end up with fist-sized chunks of metal that come out and a bunch of what they call fluff. So there's light fluff and heavy fluff. So the light fluff, you can blow air and it'll blow up and you collect it in some cyclone or something. And the heavy fluff goes down with the fist-sized chunks of metal. And then that stuff's all being separated with magnetic and eddy current separators to get the different kinds of metal from it and things, right? So that's kind of the idea. What's going on with the cars? You end up with this 20%, 20% of this chopped up, kind of blackish stuff, blackish plastic things. That's called this auto shredder residue. 10 billion pounds of it globally, right? So still it's a lot. And then 27 million end-of-life cars. And then this stuff is what you have to deal with. So what do you do with it? Because it's got in it mercury, chromium, possibly lead if you can take the battery out, right? And then it's got bromine in it. It's got a lot of stuff in it that's toxic. So it isn't just normal plastic household waste, right? It's hazardous waste. So you can't just burn it because one thing, it's got the PVC, which is the dashboard, all the naugahyde parts, like the seats, the dashboard, has chlorine in it. And when you burn it, it makes HCl, and then your entire place will rust and the people will die. But all your equipment will just rust if you burn or do something to PVC. So there's a lot of chlorinated content. The brominated content is toxic. The chlorinated just kills you. Like it'll burn your lungs out. And everything. Like we did some experiments with burning silicon tetrachloride that makes HCl as a byproduct. And we had a vent neutralizer on it and stuff, like homemade hack job, but there wasn't any that was getting into the room. Like no one was getting sick or anything. But after we did that for like 6 months, you could take the plates off the outlets, and all inside the outlet was rusted. Like everything in the whole lab was kind of destroyed. And it wasn't a perceptible amount of HCl. So it's like a little bit goes a long way. Like it's much more than what you would expect. Like you think this is a minor problem. A little bit of HCl is insane. Like, so you can't process it. You can't do anything with it, you know? All right. That guy seems happy. All right. So, anyway, so let's see, this guy's still here. Let me get rid of that. So one car gives you 4,000 pounds of waste. I don't know how they got to that. Because I think that a car weighs about like 2,000 pounds. So somehow they get one car to 4,000 pounds, but I'm not sure where that number came from. This is from Eastman Chemical. And 20% is this ASR shredder residue, which is a plastic part we're interested in. The other parts, 80% metal, none of the glass is recycled. Okay, like there's not really a reason for that, but the glass is just tossed into landfill. And then the metals, the ferrous metals recycled. But if the ferrous metal gets like chlorine in it, or it gets, no, the ferrous metal gets copper in it. So there's copper wire in there too, and in the alternators and everything. So basically, the more you disassemble the car, the better off you're going to be. But if you get the 5 to 10% copper into the ferrous, it makes it into low grade steel. Like you can't use it in a normal steel mill. Like you can't Like you have to separate the copper from the steel at that point. But the part that isn't ferromagnetic is pretty good for recycle. So I think it's like 5% of the total metal is going to be like things that are expensive. And that number goes up to like 25% if it's an electric car. Because you have lithium and all the cobalt and everything. And that stuff starts to become really valuable, right, on a recycle stream. So anyway, so 5 million tons in the US. That answers the question of the 10 billion pounds. I guess converting pounds to tons in world to US, you end up with 5 million. So it's still a lot, right? I mean, you can see the background picture of a typical kind of junkyard situation, right? There's one of these in Carthage on off 75, if you want to see one. But have you guys ever been to a junkyard? Or I mean, when I was growing up, all right, we would have junky cars. We would just get, like, if something broke, you'd go to the junkyard. You would never go to a car dealer or anything. Even for tires, like, we would go because it was cheap, right? I mean, it was, and every town had at least one junkyard. I mean, it was like they're pretty much everywhere. So anyway, so I've been to junkyards. They're messy. There's oil all over the place. Like, it's definitely a hazardous waste location, you know. And this polyurethane foam is a problem because of the brominated, because in a car accident, if it catches on fire, that's bad for the people in it. They'll burn too. So basically you want everything with anti-flammable flame suppression chemicals in it. So they put brominated chemicals in it. That's what the shredder residue looks like. It's kind of like black. And the electronic shredder residue looks pretty much the same. So people will mix the streams of the electronic waste so you can use the same facility to treat this stuff and the electronic waste, put it that way. They're both hazardous waste. So they're kind of treated the same way. That's one good thing, is you can mix those two together, but both of them are bad though. So anyway, so companies are trying to lip service this. So Ford says 85% of plastics in their cars recycle. Right? I don't think you can believe any of these people, really. You know, but maybe it's true. Probably not, you know, realistically. So Volvo's 25%. Volvo's making cars in China now, so it's hard to tell. The Chinese probably tell them it's 25, you know, whatever. So Renault, 30%, 90%. So they're all going, not because they want to do this, because they want to sell cars in Europe, which has to be 100% by 2025. Right. So there's no altruistic motive to this thing. It's basically they've been told they have to do it. So they're trying to do it. And that all the companies that like the bumpers, a lot of the parts are polypropylene that like Lyondell makes. So that's why Lyondell's so interested in this recycled polypropylene business. And I mean, so this is driving the entire thing. All the original equipment manufacturers, everyone is like running after these goals from Europe, right? So Europe is really driving the world. So despite the cars, and they're trying to make the cars so they can be disassembled into the pieces that would be recyclable, like the polypropylene parts. The problem is though, when they make a polypropylene bumper, it's fiber reinforced. If you put that into a shredder, the fibers just gum everything up. So you can't be, once they put fiber in it, it can't be recycled. It can't be put into a normal recycle stream. So then, like, what do you do with it? You know, so people, I mean, then the answer quickly comes to like pyrolysis or incineration. But if it's got chlorine in it, then incineration means you're going to rust out every piece of equipment in the factory where you're doing the incineration, right? So nobody wants it in there. And if it's brominated, it's even worse because everyone's going to die. So it's like kind of, there's this problem that they say like pyrolysis is the answer to everything. It isn't. Like the cement kilns won't take this material, put it that way, and they'll take anything. So because even in the cement kiln, the chlorine will rot out the kiln, I guess. So, or they'll get bad concrete out of it or something. But anyway, so this is just showing like the demand sectors, right, for plastics. So you have to keep in mind, like, so building construction looks pretty big, but this is like a 50 or 100-year project going on. So even though they're consuming that plastic, it's almost like already at end of life. It's already like a terminal state for the plastics. It's like a carbon sequestration. Like it's not going to go into the waste stream, not for 100 years. And at that point, maybe we'll have this business all solved, who knows? Anyway, electronic, so they call us HEEM or something is the electronics waste. And then this ESR from the automotive, right? So they're two big chunks of the package. We've already done packaging. Now we're looking at automotive. I'm going to do a thing on electronics. Agriculture, I'm not sure about. I haven't really seen that as a big thing, but textiles seems to be something big. And I think that's part of this 22%. So and even if you look at the NIST website, they have a workshop on textiles, just textiles. So there's a big push because it's, I don't know, it's like a 10-year, 20-year, depends, maybe a year for clothes, right? And then there's a turnover. And what do you do with it? Then there's a reuse sector and there's like a throw it in the garbage sector. So so textiles are a big imprint too. So automotive is like after packaging, it's more or less, it's kind of number two. It's worse than packaging because it's got all the hazardous chemical aspects to it. So the packaging is usually like not toxic for the most part, not directly toxic. I mean, if you burn it and inhale the fumes, it may kill you, but it's not recommended. This is the WEEE is electronics, electrical and electronics waste. I'm not sure what the other E is, but that's the product of TV sets and everything. Then this is the plastic waste stream. So this is the production scheme and this is the waste stream. So building and construction goes from 20% to 6% because the lifetime, the use time is much longer. I'm surprised it's even 6%. And that might be even like construction waste from when they put up a building and there's all the plastic wrap around the building and stuff, or all the wood comes wrapped in plastic, things like that. So this is probably a large part packaging, the building construction. Like the bricks come with a plastic polyethylene wrap around it. So and there's quite a bit of that. So basically, I think that's mostly packaging. But here, this is actually used, but this is probably mostly packaging. Automotive, though, is actually a real sector, and so is electronics, right? Then furniture, I'm not sure where they get the furniture thing. I'm not exactly sure how that becomes such a big cut, except it's a large mass items, but mostly not plastic, like wood and things. So not sure about the furniture part. That's the growth of cars. We saw that with the tires, like people buying more cars. Then value chain, so kind of looking at how it works. So there's the petrochemical companies, and then like Lyondell, plastic producers, and then compounders, which would be Avion, the guys that were the additive people that are going to talk at some point if they ever get back to me. And then the automotive suppliers. So these are the OEM of the original equipment manufacturers, like the there's an electronics company in Indiana that does the GM stuff. I forget the name of it. But anyway, there's a lot of companies that do. So the car companies are almost like Procter and Gamble. They buy the soap from this guy and the colorant from this guy and the fragrance from this guy, and then they mix it. So the car companies like mixing these parts that are made by other people. And I mean, in Japan, all the parts are made in Vietnam, right? So it's for Toyotas and stuff. So basically, the car companies are just putting together pieces that come from these OEM companies. OEM companies are buying from the plastic compounders to make or they're from some automotive supplier to make the parts that go into the car. So it's like everyone's getting money from everyone else. Like you're paying for it when you buy the car, but it's going down the stream of different companies. So anyway, so then finally you get to this end of life vehicle plastics into business, and then where does that go type thing, right? And then all the people that are involved in that. I'm not sure why scientists is here, but basically machinery manufacturers that are going to make the robots that put the cars together, and maybe the machines that mix the stuff to do whatever. And then politicians are always involved in everything. Scientists, not so much, but not sure what scientists, but if you look like, this is pretty good. This is from this book, which is on the webpage, automotive recycling. None of this is really, so this I think is 2009 or something. So it's not like, and I found an article is 2017 as a review that's pretty good. So, but basically some of this stuff is a little bit dated, but I don't think that much has changed really. But since the regulations in EU was like 2000, so but anyway, so the producers, they want to sell new plastics, right? So they want to say like we have a better plastic for that gear and the clock in the car or whatever, some part that turns a solenoid to do something or other. So they want to make new different kinds of plastic that are specialized to one task that are superior to whatever polypropylene you have in there. And they can sell it at 10 times the price because it's better for some reason, right? So or replace the metal transmission parts with a plastic part, something like that. Then the car producers, so variety is what the producers want because they make money on specialty plastics and they make money on composites because they're value added products, right? You take the polypropylene, put fiber in it, and then you have a bumper. That's better than a bumper that sags or whatever, right? So, and then they can make it 3 or 4 times the price because they did that. So they're making money off kind of engineering plastics. The more the plastics are engineered, the less they're recyclable. So the recyclers want to have decrease of variety. These guys want an increase of variety because they make money on that. That kills this whole industry, right, of recycling. So basically, there's conflict of interest between the producers and the recyclers. The car guys are in the middle. They want to sell their cars that have better mileage, so they weigh less, right? So the amount of plastics in cars has been going up and up and up because they want to increase the mileage. And the plastic's the easiest way to do that. There's 2 ways. You can make the engines more efficient. So they're doing that, and they've actually had huge success at that. I think the engine, like the car engines today, are something like they're way more efficient than the car engines in the past. In other words, there's been huge engineering in the engines. And then I don't know, anyone work at Cummins or anything for the diesel engines, but sometimes we have co-ops out there, but anyway, most of the diesel engines are made in Indiana, like not far from here, but so anyway, lightweight design, that's what they want. Basically, in terms of plastic, they want more of it, as much as they can put in because it replaces steel. It's cheaper and it's also lightweight, so you get better mileage. Right? And then cost and performance, right? So these guys are trying to provide performance and they're trying to boost up the cost. They're trying to reduce the cost and increase performance. They're conflicting even within their own thing. So, and then, so, but if, so these people want to have lower variety, which means worse performance. And then so defining sustainability, is it recyclable or not? Like we heard that from Jeff. Can I recycle it? Is there an end market, et cetera? And then define sustainability, weight reduction, you get lower CO2 production. And then these people are making complex things that weigh less. So they're also weight reduction. So anyway, it's a good thing to look at, like why isn't it the problem solved? It's like because of these conflicting things going on, right? And you can see the plastic content's going up, not in a huge way, but basically there's a trend that basically it's going to be all plastic at some point if that continues on, right? And the rubber is about the same, the steel is reducing. Other, I don't know what other is, but basically it's something else, I guess. But anyway, so this is one of the problems is like 48, I think it's 48 kinds of plastic in a car. People have looked at it, mostly polypropylene. Like almost a lot of it is polypropylene. So these are black copolymer or copolymer acrylonitrile butadiene styrene. That's PET, like a water bottle. This is polyoxymethylene, so it's a polyether that makes the little white gears that are like they're really tough little white gears. PVC with the chlorine, polyurethane that has flame retardant in it. So it's a polyamide like nylon, ABS, acrylonitrile butadiene styrene. It's a rubber, for the door seals. Bumpers, polycarbonate, polybutylene terephthalites. That's also a polyester like PET, but with instead of ethylene, it's got butylene. It's got 4 carbons instead of 2, and an alkane group in it. And then there's some weird ones here. SMA is styrene malic anhydride. which I think is like a glue kind of. And then PPE is polyphenylene ether. So that's a special polyester that's got aromatic rings in it. It makes it like temperature resistant. So it's like a high, DuPont makes it, right? PPE. So that's in dashboard somewhere. It's a heat resistant, high strength plastic, thermoplastic. And then polycarbonate. So there's all these different plastics, right? So you can imagine that that grind up has all that stuff in it, plus some other things. Like if you happen to grind up a solenoid that's got mercury in it, it's got mercury in it. And if you happen to get a piece of chrome coated something, you have chrome in it, right? So it's got all these different things mixed into these ground up plastic particles. This is showing like a map with bubbles to show balloons or whatever. So polypropylene is the main thing. Polyurethane from the seats and the dashboard. And the others are smaller percentages, 28% polypropylene and 64 kilogram out of whatever. They don't give the total. Oh, 224 total. So you can see like there is like a dominant species in it, but once you grind it up, they're all mixed. This is a stream of like cars in Europe. These are actually all the things I have are from Europe. So everything's like EU, but so basically some used cars come into Europe, like probably some specialty sports car or something, right? Imported from somewhere. And then new registrations, and then basically vehicles per capita 2012. Let's see, that doesn't look like per capita. It looks like total vehicles. But I think park is per capita, but anyway, so it's increasing. The number is increasing. And then rise in vehicles, 2 million. And then the end of life, well, unknown. So some of them just disappear. So these kind of junkyards have been more or less banned in most of Europe, right? So it isn't like they're going to a junkyard. So these are probably going to Africa. Like Europe, it's a pretty easy trip to Africa. Like I had a grad student whose father bought cars in Europe and sold them in Nigeria. I think he specialized in Mercedes Benz. It's like he goes to Germany, he buys like all the Mercedes Benz he can, then he puts them in a shipping container, ships them to Nigeria, and it doesn't matter. Like basically, there's a big market for it. Toyota is really popular in Ethiopia. So basically, all the Toyotas end up in Ethiopia. So anyway, so this probably is like a lot of it's just going to Africa, Eastern Europe, maybe the Middle East, but the Middle East is richer than Africa, so maybe the used cars end up in Africa. But you don't see a lot of junkyards. So people in Africa are really good at keeping old cars running too. And the climate isn't like they don't get body rust and things as much, at least in East Africa. So basically they last a long time. They keep going, like they don't stop running. And they know how to get parts and things to keep them running. I mean, it seems to work out. And then this is the end of life cars of 6 million per year, I guess, in Europe. Right. And then used car export, I guess that's the Africa route, but 1,498,000. It seems like there's more than that, but anyway, so that's kind of like the streams, the way people are looking at the streams. Car life cycles, like you can break down kind of how this whole thing's going on, right? And in the end, the final thing is like shredding. And then once you have shredding, I mean, optimistically going to recycle. In actuality, it's like 10% would do that, and the rest goes to some kind of landfill or like a incinerator of some kind, right? So it's not a right. So this is the ideal. All right, this is kind of worth watching. Maybe I can skip through if it gets boring, but let's see. What did it say? It says yes, cannot open because I didn't. Is it still? Let's see. No, I had to enable editing. Oh, here, cannot open. It's because of this. I'm not sure why that's the default mode for this thing. Anyway, this is also referenced, this exact thing is referenced in in a paper that I have on this. So, and I found this by just searching, but so see, they're taking out what is it called? The weather strip, I guess, on the side of the car. They take the seats out, they're polyurethane. So let's get the steering wheel. So those are all the components that you could sell as a separate item, right? Then it's interesting how they get the catalytic converter out. They have a special robot that flips a car over. Oh yeah, here we go. All right. This looks expensive, but the catalytic converter is like $500, I think. But this people steal them. They'll steal it out of your car when it's parked, I guess. Has anyone had a catalytic converter sold in there? I met someone that did, but anyway. Oh, you have? All right. It happens, I guess. I guess it's $500. What did it cost to replace it? That was like 2,000 probably.
Yeah, it got super fucked up.
Yeah.
It's like
Oh, all right. All right. So maybe my 500's overestimated. Because that's got to be at least twice what it costs. And then maybe they get less than that. Who knows? Was it in Cincinnati?
no, that's it.
Oh, okay. No, that's good. So they separate out the engine and somehow the chassis or something. All right, so no one really does this. This is like in an ideal world, what they would do to disassemble cars. So the engine that part probably has most of the solenoids and things that have mercury in them. So that's good that if they can separate that from the other, it cleans up the recycle stream. Then that can go to a shredder after they finish with that. They've got all the pieces in separate boxes. Right, so that's like, doesn't really happen. This is like ideal, it happens in one place, Anyway, what else is in this car? What does it say? Something process. Oh, this is a different thing. This is like the standard way. This is pretty violent. So they have the claw that gets the engine out. This is like without all the people in the assembly line. Oh, let's get the radiator or something. Like they probably have a method of doing this, but it's not pretty. So the fluids have already been drained out of the car before they start this, but there's still like a lot of liquid down at the bottom, right? Anyway, they're kind of getting the components out in a really violent way. You can watch this at home if you want, but I don't know. This cloth thing could be pretty dangerous. Oh, then they crush it. After they're done with that, they crush it. So I don't have a picture of the shredder, but basically after all these things, after they finish it, see, it still has the dashboard in it. So it's still got brominated polyurethane in it. Who knows what else it still has in it. So this is where you're really toxic. They're gonna end up with a bale after this. Like the whole thing will be just crushed down to a bale. And that thing, see the steering wheel's still there. So they're gonna make it into a bale and that thing will be fed into a shredder. And then from that, 20% of that's gonna be plastic. This is the baling machine, I guess. At some point they end up with a bale. Oh, this is the shredder. All right, so the shredder is versatile, da, 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 is whatever it says. Oh, there's the red car. So I guess they're just feeding it in like that. So that's gonna make this shredder residue, ASR thing, automotive shredder residue. It's not pretty. I thought I had watched this whole thing, but there's another car going through. And then the shredder residue is going to go through a magnetic separation. And I'm not sure what that is. Oh, this is tires. This rest of this is tires. Anyway, there'll be a magnetic separation to get the metal out, the ferrous metal, and then they'll go through an eddy current to get the things that are like aluminum and magnesium and stuff out of it. I'm not sure I watched this all the way through. I just remember the first part, but granulation line, aggregate granule refining. So anyway, you can see that it's a big time operation, but again, like most places are just doing the claw thing and then shredding it. So, and they end up with the plastic residue, whatever from that. Anyway, so I thought that was kind of interesting. So let's see. Well, on my plastic waste. So recycling and then energy recovery is burning it and disposal is landfill. Right. This is EU in 2008. So basically a large chunk of the residue goes into landfill. This is for the plastics waste. The metal waste, so the 80% that's metal all gets recycled. That all goes into a metal waste stream. Plastics content of end-of-life vehicle, mostly polypropylene. And this is something, a different view of like what the companies are doing. So 35% for Fiat, and then no one indicates for the others. BMW up to 20. So as far as recycled plastics. Then this is the EU 2000. So supposedly like 2006, this is the cuts they're supposed to get, and then 2015 they're supposed to get that. So I think those were not met, And then now you saw what I said before about Ford having this 85% or whatever. This is where the number comes from, because the EU 2000 rule made them do that. But then this is just kind of a summary of all from this book about all this business, but I think I already said most of this stuff. So what's this? So yeah, that's just another table. Anyway, these are the bromine compounds of flame retardants. So these aromatic, they're what's it called? They're ethers, right? Biphenyl ethers, I think they call it. Diphenyl ether. Right, so you have two phenyl rings and an ether in the middle. And you brominate it to the extent you want. So the whole brominations, this octo, there's a penta that's got 5 bromines stuck on it, right? So somehow this prevents fire from happening. Anyway, this is the hexabromo is in electronic stuff. They give examples: computer monitor, photocopier, and the tetrabromo. It's penta, is 1, 2, 3, 4, 5. Tetrabromophenyl ether, pentabromophenyl ether. This is penta. This is octo. So those are in the polyurethane foam seats for whatever reason. I mean, I'm not sure why they have different in the two, but long range transport, persistent in the environment, they accumulate in humans and then transform into brominated dioxins when you heat them up and burn. So basically nasty, not good to have around, but necessary. I mean, so they save lives on the front end when you have a fire and it doesn't, like, you don't burn to death, but they get you on the back end by giving you cancer. So that's the bromination story, right? So variable mix of thermoplastics, and it's not a uniform mix, so it's kind of like, yeah, and there aren't good ways to test this mix of mud, wood, dirt, stones, whatever, mixed in with rubbers and thermoplastics and thermosets. So that there isn't a good test. You can say this is a good batch or a bad batch. And then most of it will have like mercury, lead, cadmium, polychlorinated biphenyls, and BFRs are dioxins, I think. I think those are like a dioxin thing. But brominated, this is chlorinated biphenyls, and this is brominated something, bad stuff. So it's basically hazardous waste. All this auto regrind plastic is hazardous waste. So it has to be, that puts it in a different category So people have been landfilling it for a long time, so there's kind of a tradition. So they do leachant studies to see if what comes out of it, and then it's okay for a landfill. So this stuff is going into landfill for the most part because of the problems with burning it. So pyrolysis incineration are problematic too. So average lifetime of a car is 13 years. And then basically there's this transfer of cars to Africa, Asia, Eastern Europe that gets you out of the stream, right? Then scrapyard for cannibalization, and then the systematic dismantling that was in that video, which is probably what the ideal is for this system, but someone has to pay for it. And there isn't, the product from this isn't going to pay for that systematic dismantling. So it can only be done through regulation and through basically this idea of extended producer responsibility, which is the key to that 2020 law in the EU. In fact, that was the origin of it. So the 2020 EU law for cars said that if you made a car, you're responsible for disposing of it when it's done. So that got all the car companies to say like, oh, we got to do something, right? And that's where this disassembly thing came from. So basically that they invented at that point this and extended producer responsibility has become like a catchphrase for like packaging people like Lyondell. And so everyone's worried about extended producer responsibility. The nice thing is if you have that, you can't be sued. So your liability goes away because as long as you follow the rules for extended producer liability, you've done everything you have to do. Even if people get cancer from brominated whatever when they drink the water from the landfill. Right. So basically the companies like extended producer responsibility takes their liability off. Liability is a much worse thing than knowing what you have to pay. Like when Dow Corning was making silicone breast implants, and there were like very vague symptoms to it. It was like, I don't feel good type thing. And they could sue for like $100 million if I don't feel good for something that, anyway, that happened. They went bankrupt and when going bankrupt, they could go back into business, right? But they weren't producing any breast implants after that. But basically, because they could get out of the liability was worse because they never knew like anyone could sue them for $100 million anytime. And they were suing them continuously. They couldn't afford to litigate like that. So basically getting out of the litigation, they would much rather have a federal law, extended producer responsibility, that you have to take the car that you made and recycle it, than have the possibility even that you could be sued because your stock price will go zero. That's what happened to Dow Corning, and they were a pretty good company. Then they like went bankrupt because of that. So, wait, the legal thing is kind of a double-edged sword. You know, it's good that you can drive people to do stuff, but it's kind of bad that people that didn't really do anything can also get sued. You know, so it's a funny thing. But anyway, that's kind of my opinion on the breast implant thing. But I mean, there's other views too. But anyway, so fiberglass bodies are terrible for this whole thing. They destroy the shredders. Like, so you think like, oh, if you can make lighter cars, get rid of the steel, you have to also consider that it can't be recycled then. So you have this huge pile, like if every car was a fiberglass car, yeah, everyone would be getting like 10 more miles to the gallon. But basically, there would be no possibility of recycling the 80% that you're recycling now in the steel. So you'd have big piles of fiberglass bodies or shredded plastic made of fiberglass bodies, which you can't even shred because it jams the shredders. So it's like you have to figure out a way. And one way is you can take the stuff, and people have done this, take the entire car, freeze it with liquid nitrogen, and then everything becomes brittle, including the steel. So below -50, steel becomes extremely brittle like glass. So you can take the whole thing and just whack it and just shatters. But you have to freeze the whole car in liquid nitrogen. So they built a plant to do this in Europe, apparently. And it could do it, but the cost was so high that they just stopped doing it. You know, the cost for doing that was insane. But anyway, so these are the laws, I guess, for this. So the first group was Switzerland. So it was before 2000, it was in 1990s. And Switzerland and Japan pushed in the Netherlands, pushed this idea of pyrolysis of the shredder residue. Then EU followed that, and then EU came up with this 2000 law. And they come through with several other laws about end of life vehicles, right, that have kind of led the way for the world, really. So no one else is really regulated. So basically, these are what the EU rules for car makers, reduce their use of hazardous, whatever. So that upfront end, like use less of this stuff, which they've succeeded in doing. Then standards for labeling the plastic parts. That's kind of, right, it's a little strange, like if you're gonna grind it into shredded ASR, it's not gonna make much difference if it's labeled, but if they have this disassembly process, that could work, right? So then the states, the EU member states have to set up collection systems to make this work for the end-of-life vehicles. And then you're going to have a lifetime for the car, have a certificate of destruction. Like when it reaches end of life, you have to produce that. Otherwise, the government will come after you or something. I don't know what the penalty is. I think the penalty goes back to the producer because this is a extended producer responsibility law. It's basically the whatever Chrysler is going to be chasing after you to get your certificate of destruction after 13 and a half years. You'll be getting some kind of phone call like, where is the certificate? Or somehow I'm not sure how they implement that part. But this is the thing. So the government, through the companies, will pay the government to dispose of all the cars for free take back. That helps with the certificate of destruction. And then dismantlers need to have permits, so they're going to control the whole operation. So there isn't just like someone spraying whatever brominated whatever in the streets of New Jersey at night, whatever, whatever they do. But it goes back to the mafia and the garbage collection thing. But anyway, so storage and treatment of ELVs strictly controlled. End-of-life vehicles, designated part removal. So they made this a law for the whole of Europe, 3 member states required to report on implementation. So every 3 years. So it's the first extended producer responsibility law, and it's got this comprehensive, well thought out plan. I mean, the car companies like this because their liability is gone. Then it's like, as long as they check all these boxes, they have zero liability for anything. Right. And basically they can pass the cost on to the consumer. Like you buy the car in Europe, it's going to cost $1,000 more. And basically basically no liability and pass on the cost. That's a solution to the problem. It's good. So yeah, the residues, hazardous waste, most of it's landfilled at this point. Let's see what else I got here. Then this is the rest of the world. So Japan does some stuff in Korea, South Korea. So these are like the 2 leaders in the rest of the world, Japan and South Korea, and they're basically not doing much. Then the US has this idea of product stewardship, which means there are no laws, but we trust you because you're a steward. And then shared responsibility means the company, the car maker it's the consumer, the company, and then whoever's dealing with the mess share the responsibility. And maybe the government too, right? So there's no laws, there's no mandates. It's just, they just have some ideas. So you can ask Kate, like about that business, like, why don't we have any rules? I mean, she's in the government, so she represents them. So you could hold her on the spot for it, I guess. But there have been some industrial groups who kind of lip service it in the US. I think that's what it is. And then this just goes through the steps, like decontamination, flattening, shredder residue. So they call like light fluff and heavy fluff are technical terms for what comes out of this. There's fist-sized metal chunks, light fluff and heavy fluff, and that these are go through their own separation processes. And then that's composition, table of compositions. This is kind of interesting. I wish I had this for the other thing. This total recycling, showing like what people are doing for the total recycled plastics, right? So, I mean, Switzerland's doing great. 100%. Right, and then Lithuania is doing terrible, but basically, it's nice, I wish I had had this before, because it pretty much shows. So you'd say Switzerland's doing great, but most of its energy recovery, Germany is actually doing the best, because the actual recycled stream is like 35%. And then the rest of it they burn, so that, and then they end up with 95% recycled for all plastic, right? So these countries are doing like great, like compared to us, it looks pretty nice. Anyway, so wait, there's another video. I'm not sure. Oh, this just shows like what they're doing. So there's companies that separate this shredder residue. This is short. This just like shows. There's only one company that does this. I mean, there's several, but basically this is the only one that actually has like something to look at. The beginning is just junk, and there's some machines like. So they're doing, the stuff comes in a truck like that. The semi is like completely filled with it. I'm not sure how they filled that. And then they put it into their machines, they shake it and do separation processes. Like some of it is density, a lot of it is blowing it through air so that the heavy things go into one stream and the light things go into another. And there's optical sorting, like this kind of business is flying out. Then they have this also with put an electrostatic charge on them and then separate by electrostatic charge for the different kinds of plastics. There's a few different things. They do a density. These are all kind of density, the things in the air. So in the end, they get bales with different kinds of plastic out of it, even though it was a complete mix to start. Like their main goal is to separate out the ABS, the acrylnitrobutadiene styrene, that could be repelletized. So you see they have these bags of ABS with certain cuts of other things in it that they claim they can sell. I think this is in Germany. But so there are companies that are doing this. I don't think it's like widely done, but this Hamos company. What else do I have? Well, kind of over time. Why don't I'll just finish this off on whenever, next Thursday, I guess. Because there's a few more things, and then these are electric vehicle things. So why don't I'll finish it next time, because I think I only want to go an hour, that's an hour. So anyway, so yeah, Thursday we'll have Katie beers from this, and hopefully that'll work out. Uh,